Hi science students, today we're going to talk about solubility and temperature. Yesterday we talked about solutions and what makes them soluble. So today we're going to look at one variable that impacts solubility, temperature. So we're going to use a gizmos to do that. You should have already copied down the questions from the worksheet before beginning class. If you have not, go ahead and copy this down onto a sheet of paper. Let me make it so that you can fit it all on one screen. If you need to pause the video in order to copy it down, go ahead and do that. But we're going to go through and discuss these specific questions using the gizmos. This should give you some practice to be able to effectively do the lesson for today. So if we're looking at this solution, we see some water here, 100 milliliters of water. We see a funnel to be able to put in some substance. We see different substances to choose from, but we're going to use potassium nitrate as our substance. And as we go, we're going to add in some different amounts of substances to see how much substance or solute that the solvent can hold. So before beginning our gizmos, we're going to look at these first two questions. If I'm looking at a solution being made of water and of potassium nitrate, I know that my solute, what is being mixed or dissolved into the solution, is going to be potassium nitrate. And I know that my solvent is going to be what's doing the dissolving, so it's going to be water. With this information, we can go ahead and move forward knowing that we're going to be adding in solute of potassium nitrate in grams in increments of 10. So we're going to make sure that our substance is set to 20 degrees. It is. It's right here. We want to make sure that our substance is set to potassium nitrate, and then we're going to click OK. So we're going to start adding in. We need to add 10 grams, and you can track how many grams that we've added right here. So I'm going to add in 10 grams. I notice that there's no grams piling at the bottom. So I've added in 10, and at the bottom, I have 0 grams piling. At this point, it's probably unsaturated. I can probably add more in and it will still dissolve. So let's do that. Let's add 10 more to make 20 grams. Right now, there is nothing piled at the bottom. So again, I'm going to put 0 grams piled at the bottom. Let's add 10 more, bring us up to 30 grams. I don't see any pile of solute at the bottom, so I'm going to place another 0 here. I'm going to add 10 more to get me to 40 grams. And I want to look at this bar chart. I notice that I've got 40 grams added, and it says that, and then it tells me at the bottom how many I have also. This says I have almost 10 grams at the bottom. So what I want to record into my data table is going to be 9.35 grams pooling at the bottom. As I continue, I'm going to see a pile show up, but visually right now you can't yet see that. So let's add 10 more because that's what our data table tells us to do. So we're up to 50 grams now, and we can kind of see a small piling crystallizing at the bottom of this supersaturated substance or solution. So I want to add in at the bottom that I have 19.35 grams. I'm going to add 10 more to bring me up to 60 grams, and I can now see that I have 29.35 grams total. So what you should notice is that the saturation point of potassium nitrate in water is how much substance I can put in and it still dissolve. Once it begins piling at the bottom, you've reached and exceeded your saturation point. So at this data table, I know that my saturation point would have been 30 because I still had 0 piling at the bottom, but it was still dissolving into the mixture. So when you do the assignment today, you want to keep adding grams of the substance in until it no longer is dissolving. Once you see a pile at the bottom, it's super saturated and you need to take out what you put in, and you want to put in one by one until you figure out how many grams will dissolve without piling at the bottom and becoming super saturated. We don't want a pile that looks like this in our simulation for today. We want to stay at that point where it's all dissolving and disappearing into the water. If it's piling at the bottom, you've super saturated your solution. So let's look at these two questions at the bottom. It says, at what number of grams added did you notice that any solute at the bottom? So I know that at 10, 20, and 30, there was not a piling of any sort of grams at the bottom. So I know that at 40 grams is when I saw the pile. And the second question says, how much solute was there? I'm going to look at my data table, trace across from 40, and I have 9.35 grams at the bottom. All right. The second question said, what did you notice about the data at the bottom when you added more? When you went from 40 to 50 and then from 50 to 60, you should notice that as I added 10 more grams to go from 40 to 50, my pile has 10 more grams in it. I went from 9.35 to 19.35, meaning that none of that substance I'm putting in is actually being dissolved into the water because the water is filled up. Instead, it's just sinking directly to the bottom and piling there. So I'm going to add here that solute at the bottom increases by 10 grams as I add 10 grams to go from 40 to 50 to 60. No solute is being dissolved at that time. It is all sinking to the bottom. Because the substance is super saturated. So what I also want us to look at while we're here together, but we're not actually going to record anything, is I want us to notice the relationship that temperature has with the amount of substance that we can put in. So we're going to go back into our simulation, and I'm going to change the temperature a little bit. I know that my solution became saturated. When I was at 20 degrees, my solution becomes saturated pretty quickly. I can only put in 30 grams that will still dissolve before it begins piling at the bottom. That piling at the bottom is telling me that it is now a super saturated solution. So I want to stay at the rate where it's saturated and will dissolve, but will not begin piling at the bottom. So I'm going to increase my temperature, and I should expect to see a change. If I'm increasing the temperature, I should see more solute being able to go into the solution. My saturation level should be higher. So let's see if that's true. I'm going to change it up to 60 degrees, and I'm going to add in 20, 30. This is where it was saturated at 20 degrees. I'm going to keep adding 10 more, so I'm at 40, 50, 60, 70, 80, 90, 100, 110, and 120. So at 110, I was still able to dissolve the solution into the water, and at 120, it became supersaturated. So my saturation rate would have been 110. I know that that's exponentially higher than a saturation level of 30 grams, and that's because of the temperature that's been increased. So let's just check that that theory is right. We're going to change this up to 100 degrees. and as high as it'll let me go is 95. So I'm going to again see how much I can put in at 95 degrees. I should expect if I've increased my temperature, I've increased the amount of solute that I can put into the solution and it still dissolve. So let's put in 20, 40, 60, 80, 100. We're going to surpass where we were at our saturated level at 110 for 60 degrees. So 120, 140, 160, 180, 200, 220, 240. So I notice at 220, I was saturated and there was nothing piling at the bottom. But at 240, it became supersaturated. So my saturation level would have been at 220 at 95 degrees. I want you to notice a direct relationship between an increase in temperature and an increase in the amount of solute that a solvent can dissolve. If I'm increasing the temperature, I'm increasing how much solute I can put into the solution. That's our entire lesson for today. Have a really good day, stay safe, and I'll see you tomorrow.